I'm so sorry. I'm like, why can't I see this? I told you when I get on stage. Let me just go back. So once upon a time, a long time ago, when I was in school, I remember hearing this quote and thinking, having a very visceral reaction to it. Like, what's the point of doing this if all models are wrong? And then, of course, my professor then added in cheekily, but some are useful. And over time in my career, I have found it to be so interesting and so true. And it's funny when I look back at starting off into this journey about how I was so angry about it, and now over time, as you know, you go through as data scientists and you build models and you create things you're incredibly proud about, and you share it, hopefully, to the world and other data scientists around you, and you give back in terms of mentorship. But you look back at some of the things that really affected you as a person as you went through that process. And at least for me, I evolved and changed my perspective. And so I'll tell you a few things ahead of time. I have presented at this conference since its advent. I have always presented very technical, having all my code on the thing, going very deep into it. Today I'm going to show you my GitHub. I'm going to ask you to take a screenshot of it, and there you'll have your code, because I'm trying to pivot this conversation and take it a little bit into a different place. So please stick along with me as we go through this journey together. And I'm going to start off with a cheesy dad joke of the morning. And if you know the answer to this and are brave enough to shout it out, I may have a prize for you. Nothing great. Don't get your hopes up too excitedly. But my son gave me this joke. So how much does it cost a pirate to get his ears pierced? Does anybody know? I don't know who said that, but you got it. So the answer is a buccaneer, which I just thought was hilarious the day he told it to me. So wait, can you raise your hand who said that? All right. Can you find me afterwards, because I can barely see you? I didn't think anyone was going to get it, actually. So that is awesome. Why I do that is just to sort of set the stage for the fact that this is going to be a little bit different than maybe you wanted to come here. I don't like 9 a.m. presentations that are overly intense in terms of information, and that's why I've taken the feedback I've learned at the many conferences I presented and decided, go here. I think I have 255 repositories, everything that's evolved. And what I was going to present on today, which was going to be this intersection of knowledge graph and LLMs for healthcare, is right at the top. And so you'll have all the same great information I would have presented, but I want to talk to you today as people, because I have found in my organization that everybody today is an AI expert. You know, that's one of the great sort of democratization that AI and all these co-pilots in Microsoft have given us. But the reality is that us who've really been born up in the data science side of this, you know, not everybody is an expert in that space. You know, I went to school to be a quantum physicist and fell in love with statistics part of that program and thought it was so amazing that you could tell stories with data in a way that was very provocative, and it inspired me to build a career around it. That and NASA wasn't hiring when I came out of school, and so I pivoted to Apple. And it's okay, because here I am today, and it's a great choice. My uncle may disagree. He works at NASA, and he's always telling me, I built the GOES satellite and launched it. What'd you do today? And I'm like, I built a model. Never seems as exciting at the dinner table, but okay. One of the provocative ideas around AI that I've been noodling a lot on is this idea of artificial general intelligence. Now, I know some of you are going to love it. Some of you are going to immediately hate it. You know, this is one of the most polarizing conversations, like sitting around at a conference I've ever seen. I wasn't expecting that, but it is. And so no matter how you feel about AGI and what AGI can give us when we finally get there, and we are not there, in my opinion, today, you know, objects that are continuously connected, you know, think about your autonomous driving vehicle. These things have a set of rules around them that make them able to function that way in our physical space. It's just the physics of it. Things like objects don't suddenly materialize, persistence, and they don't act off in a distance and interpenetrate each other. There's just some rules of physics that go along with the laws of what we need to make AGI possible. But how do you make AGI fair when it comes to the machine side and humans? And can we measure that same level of knowledge to get to AGI that a human has and be able to use that almost as an intelligence test for the machine outside of what Turing does today. I'm trying to look for those innate human factors that make us who we are. And I propose that there is a set of factors that we can use to measure humans around that will somewhat level the playing field when we look at machines. And really, I'm centering at least my conversation today around this idea of a set of knowledge priors. And what do I mean by that? All right, so if we're going to think about this in an organizational sense, because my presentation today is how it affects behavior. And the reason why this is important to me is because I have hired many, many people to work for me. And some, I would have said during the interview, are going to be the people I'm going to promote into leadership. They're going to be great people managers. And some are quiet, very thoughtful, don't speak up all the time. And as I was a new leader, I didn't understand that that doesn't mean I'm going to promote the loudest person in the room because they're take charge and go forward. But maybe the thoughtful person in the room is just as good of a leader, but has social qualities about them that doesn't sort of hit the cultural standard of what we consider a leader in America. And that paradigm shift for me was like my own general intelligence starting to evolve over just understanding my people and management. And so I have a belief around this idea that every person that comes into our workplace today has a set of knowledge priors they have learned. And we can measure that and actually quantify what that means in a space that makes it equal for all people, not just the loudest in the room, not just the people that are saying, give me that, I can take charge, I want the position. So for example, and I think we can apply this then to as we move towards AGI. There are some common laws that we know, and I'll give you one of them, when we think about agentness and goal-directedness. If I were to tell you that agent A is fleeing and agent B is pursuing, we can make some assumptions around that these are objects that are orientated in action. There's a reciprocity between them that we can assume, which we can assume that if one is being followed or chased, that they're being chased and one is fleeing. And so that behavior pattern tied to your knowledge prior, and what I mean by that is what you've learned in your past, all the little things you've picked up over time. Can we quantify that into an algorithm or a formula that then gives us the first step of understanding that particular feature of a person? How fast did they learn that set of knowledge? That then gives us somewhat of an even playing space that isn't just the fact that maybe you were privileged to go to a school that gave you a world of information and knowledge, and maybe you were not privileged to go to school and you don't have a degree yet, but you've picked up life lessons that should be measured equally amongst this group of people that today aren't. People ask me all the time, I need a PhD before I come interview for you, and I tell them no. I mean, I'm just working on my PhD program now because I'm tired of people coming into a room and, assuming that they know much more than myself, and you play stump the chump, and then in the end you win. You're like, yeah, and I used to love that. Now I just want to be like, I have this. Some industries value it. Some don't care. I'm in tech. Most people I've hired don't even have degrees. And that comes back to this knowledge prior. It's because those people that came in and interviewed for me had something that it just resonated with me. I saw that in them. And so I started building this formula around the idea of, well, what is that set of things that they brought from their, hard knocks life or their life lessons or the things that they bring with them. And that's what I'm calling my knowledge priors. I wanted to determine how fast that they learn these different skills and tasks, and can I program this to say, is this something that I can measure broadly to make it as fair as possible? Because if you give two individuals a test, one's gone to Harvard and had all this privilege and information to learn, and the other one has not, but they both functionally know the same task they're trying to get at, how do you really bring responsible AI to that? How do you level that playing field? Well, let's look at how fast they each learned it, because that is the digestion of that task into intelligence. So then it doesn't matter when you're looking at somebody who's been given and afforded a different set of information. You've taken out the fact of that information, and you're now looking at the speed by which you turned it into intelligence. So that's really what I'm purporting here. Now, I'm not purporting this is the answer to everything. It's just what I am right now analyzing and researching as part of my PhD, and that's what I wanted to share with you. And I would love, by the way, feedback. One of the things I also think is really interesting is that last night at the amazing happy hour, I was blown away at people that just came up to me and started talking. Because I know when I went to conferences in the beginning, my social anxiety would say, oh, no, they're having a much more important conversation. Or, oh, no, let me find them later. I'll go quietly and tap them on the shoulder like, hey, can I take your time? Like there's some pedestal person that I can't just walk up to. And last night I had people coming up to me and just telling me ideas and things that they've been thinking about. And I thought that was so amazing to see this sort of world around us evolving into how we feel a network that we can build and just walk up to people and have conversations. And so I just wanted to add that those who did that last night with me, thank you. I loved it. I wish I had been that way 20 years ago. All right, so I'm looking at sort of the 4 categories around these knowledge priors that I wanted to see if I could formulate measurement on. And here they are. And so think about this in the sense of the physical world. These 4 things are what I believe are going to level the playing field when it comes to responsibly being able to define who makes a good leader. Because I want to get down to a point where I can say, I'm going to measure everyone apples to apples in some sense that takes the personality out of it, that takes how loud you are and how in sort of your remembrance because your loudness, and brings up maybe the potentially quiet one in a different way that maybe isn't as comfortable walking up to someone like myself. I was lucky enough to have a leader who saw that in me, and I want to know if I can quantify that. So these are the 4 areas that I have put down and started to, from my hypothesis, analyze and start to measure. And that's around the idea of, as I mentioned, the objectness, and the elementary physics. And that's purely what objects don't appear and disappear, like cease to exist or suddenly exist. I mean, if you believe in immolation, some other things, that's an entirely different world of the physical world. But in general, these things, that's what persistence is. They persist. They also, have an agentness or some type of directedness, meaning they have a goal, to do something. They are not inanimate, and these agents have intentions of their own often, which means they have an understanding of where they are in their world, and that's the elementary geometry and topology. We have an innate understanding, even as children, in a 2-dimensional and 3-dimensional space about space. We learn as we interact with things that may hurt in that space, but we still have an innate understanding of space. Now, when you augment that with 4-dimension, we can't do that as humans right now. We can't have that same level of processing to overlay, and that's where we have to level our machines and how we work with machines. So in a Turing test, a machine is going to always be far superior in that space. So then again, we're not creating a level-to-level space of AGI. So I'm going to keep comparing getting to AGI to being able to measure humans and their intelligence, because I believe they're very correlated. And then, of course, our natural numbers and elementary arithmetic. In general, they say that everybody can do simple math, addition, subtraction, ranking in their head naturally. Now, I'm not asking you to rank to a huge dimensional precision point of, say, pi to 16 points, but you have an understanding once we learn to start counting forward and backward, what is higher, what is lower. That's a generalness of what I mean by natural numbers and elementary arithmetic. Okay, so those are 4 sort of basics, not defined by me, defined by human scientists, human psychotherapists, and psychometrics analysts that have studied this over time. So I'm going to make some assertions and assumptions. I'm going to absorb that as part of my hypothesis and say, can we use this now to measure intelligence of employees? And by the way, in that GitHub repository, you can follow along with this project if it's anything you're interested about. You may not care at all, but I actually think it's really interesting to the point that our moderator was saying this morning to look at how we work with people. I just think we talk about responsible AI so much, and we say we need fairness, and we need to have lack of bias, but DEI programs are getting canceled, and I'm not trying to be political here at all. I just want people to have a broader thinking about people in the room and how they can promote others that may not have a voice as strong for themselves. And so that's why I put this together as a quantifiable way as leaders that we can go and measure our employees that isn't from a performance review, because those can be skewed, isn't from just your perception of them, but it looks at some leveling playing fields that we can use as metrics on who would make a good leader. That's computational science. And who would make a leader that will stay in your company? Even more important. You could also invest all this time into one person and they still leave, because at the end of the day, there's a better opportunity outside. And that's why I purport, if we did this earlier with those that we could start as they come in very fresh into like the world of working for you, I believe we'd have a little bit more stickiness to retain and do things with them. I could be totally wrong. But that's how my impression of my career has evolved and changed over time. And so applying this measurement to who should be promoted into leadership, I'm using just the algorithmic information theory. And I'm not going to go into a bunch of definitions around it, but it is, in essence, can we write algorithms that can measure facets of human intelligence? That is the theory of AIT. And this, the central sort of theorem of this is, like I said at the beginning, there is an efficiency to our skill acquisition over any scope of tasks with respect to what you know coming into that system, your experiences, and the generalization difficulty. And I think that is the more fine nuance of this. There's 3 or 4 different types of generalizations that occur in information systems, and quantifying that piece of it is where AI systems right now fail many times. That's why people started running to RAG for fine-tuning, and that's, I'm going to laugh in some instances. I mean, there's probably some world where RAG works really well. I believe RAG is not the thing that's going to be the fine-tuning mechanism. So again, don't shoot me if you have very strong feelings. I've seen some great RAG projects, but I've seen a lot of real-world implementation that doesn't work. And again, in the GitHub, there's many examples by many industries that you can go see of why I purport that. But I just believe that if these two systems or people, have similar knowledge that they're coming in, and they have a task experience that I don't know in advance when they come in. I don't know how fast they are at doing any one thing. I can start to measure this by monitoring and watching them and get a sense of, okay, if we all have the same task to do, I get that you'll do it your way, you'll do it your way, and that's okay. But how fast you get to the end result is the measurement I believe can sort of level the playing field to just understand, at a start, how fast did you pick up that task I gave, if you're my system, and then how fast did you turn that, your intelligence, your knowledge priors, into a sort of intellectual, measurable system, or what I'm calling a win. And you can think about this as RL advanced. Lastly, this becomes the foundation for AGI at its core. And I think that's sort of what, George's aphorism is really centered around. It is not meant to provide you a be-all, end-all of perfection, and we data scientists often want to train and retrain till ad nauseum. I was definitely at fault of that, wanting perfection. Perfection is definitely the killer of good enough and being successful. And I believe just the point of all of this, whether you apply it in humans and measuring them, or you apply it to broader thinking, is to have a useful North Star that you're trying to achieve, and then be flexible towards getting there. It's the idea of it's not the destination, but it's the journey on getting there. I believe that's very true in systems as well. And so if I had to bucket this down simply of what I'm thinking about and sort of the position of the problem here, it's this idea that you're going to have an intelligent system, and that choice of a problem setup is much like the same problem that you could measure in supervised learning, partial supervised learning, and reinforcement learning, where you have a system, you have a set of skills or programs, you have a feedback mechanism or a feedback loop, and then you have your task that you're assigned to do. And essentially, it is that interaction between task and the intelligence system that is mediated by this skill program. And that's the intelligence system of the person. And then, of course, the scoring function, which is just a part of the task. Did you do it? Did you not? Did you complete the game? Did you hit the end? And that fixes us into a situational response space that we can measure. Think of it like a sensor space or a motor space when you're looking at robots and how they traverse their ground. I get lost watching my robot vacuum, now mopper, do a pattern like this in my living room. And then it knows, it's very smart to know where all the furniture is for the most part. Sometimes it gets a little confused and it will fight its way like, I am going to get through this chair if it kills me. And that is part of this idea that it has a task that it is set to do. We as humans have teams of people that have tasks that they are set to do. If you take that and just neutralize the playing field and say, okay, that's a given, there's no right or wrong. We don't want to reward people that just because they went to a great school or they had opportunities in terms of experiences that we were given. So we want to remove that. And we just want to look like task to task in the same sensor or motor space of the workplace. Can we level it out by just measuring how fast they do as a baseline, these pieces of the tasks that we give them, how fast do they take that feedback, reprocess it, and then come out with this intelligent system, if you will. I know I'm asking you to think a lot at 9 a.m., and I know I'm asking you to think very heady, but I think this is a core problem of AGI that we have to solve anyway. And that is, there are a lot of today assumptions that are being made in a theoretical world. There's a lot of assumptions we make about people. You look at me today and you might be like, I hate this presentation. I wanted to see all the Python script. You may look at me today and be like, I don't agree with AGI at all. I don't know what she's talking about. But what I want you to leave here to think about today is that there's no right or wrong answer to what I'm presenting today. It's about changing the paradigm of how we think to potentially explore something that we never thought we would explore. I never thought, in all the times I came to show you all my awesome code and the things that I've been doing, that I would ever have this conversation. But I think very differently now. I think people are an asset that we cannot, forget about. And I think the more that we try to just rely on the existing systems of performance review to judge people or a bell curve to judge people, the more we forget about the innate qualities that people bring to role, that they're not always going to speak up and say, hey, look at me, I do this. And how do we then reward them and encourage that so that we continue a generation of people that are curious? And that's the last note I'll leave you with, is that if I can do anything in the success of this program, and I hope by next year when I come back, this will all be fully baked and I'll have a better answer for you, because this is very early on. And as I said, you can go see my knowledge graph LLM that I was going to present on my GitHub and get all the code you want. But I hope to come back in a year and showcase how I measured and how I, took this to analyze and study my hypothesis to see yay or nay. And I will tell you, if it's a totally terrible hypothesis and it failed, here's why. I will bring that set of knowledge back to you. But I believe that we can do everything in our world to get more computationally efficient with our code we're running. We can have better time management, some of us. I'm looking at my time, I'm like, ooh, gotta speed up. We can do everything to mitigate risks that many of us don't even think about, and that's the important one. You may not realize that you're often exposing your company and yourself to so much risk in just the activities that we do, because going back to my previous speaker, that said, and I thought with great power comes great responsibility, which he didn't do, which was a plus for his humor. But it's true, and we as humans are burnt out. And that burnout level it's a thing. And that's why I believe if we can measure this and understand what it takes to really inspire, create that new skill program, which is all around the paradigm of leadership in the company, and then turn that into translatable outcomes, maybe curriculum, some set of instructions that we then encourage our team to do, then we take out all this sort of bias factors that come into the system that we may or may not that we do. We'll find out if this is true when I come back the next time. And that is my presentation today. So, thank you.
Thank you so very much, Laura.